and welcome to Lesson 4 of our Chapter 4 unit on atoms and elements and those ionic and covalent compounds. We have already learned that the periodic table represents all of the known elements and that an atom is the smallest particle of an element that still maintains the properties of that element. All atoms are neutral, so that means that the number of protons equals the number of electrons, and that atoms don't necessarily have a full outer valence shell, so they're going to react with other atoms in order to get that full outer shell. When atoms react together, if one is a metal and the other is a non-metal, we call this an ionic compound, and the electrons are transferred from the metal to the non-metal. This is very important for you to remember that for ionic, the electrons are transferred from the metal to the non-metal. Covalent, however, is between two nonmetals where the electrons are shared. Please take note of the difference between ionic and covalent compounds. It will help if you understand which elements on the periodic table are metals and which are nonmetals. So we have shown these atoms and ions and compounds with Bohr and Lewis diagrams so far. Now let's recap on one of them. So for example, sodium. This is the Lewis diagram for sodium. It only has one electron in its valence shell, and chlorine has 7 in its outer shell. They're going to come together. That electron is going to get transferred over there, and we're going to get sodium with none in its outer valence shell, but it's happy with 8 in the shell below. And then chloride, 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. Now take note of these numbers up here, the top right of the brackets. That +1 for the sodium is referring to the fact that the protons and electrons are no longer balanced. For the atom, it has the same protons and electrons. Now it has one extra proton that it has electrons because it gave away an electron. So it's +1. For chlorine, it was unstable, but it had equal number of protons and electrons. But now it has gained an electron from that sodium, and it has one more electron than it has protons. So one extra electron makes it one more negative. So here's what sodium and chlorine look like when they combine to make sodium chloride. They make this cool crystal lattice structure, and we know this in our everyday lives as salt. So ionic compounds can be described with images such as these, or we can describe them by name. So today we're just going to name the ionic compounds. So metal transferring electrons to a nonmetal. The positive ion is always written first, and this is the metal cation, because the metal, remember, loses the electron, so it becomes positive, and in our example this was sodium. So the negative ion will always be written second then, and this is the nonmetal. And we know it's the nonmetal because ionic compounds only happen between metal and nonmetal. The nonmetal is the anion. It gains the electron. When you're getting more electrons, electrons are negative, so you're getting more negative. The nonmetal's name will change. So we went from chlorine, and it's going to change, so the ending ends with "ide." So chlorine will change to chloride. 3 things to really take note of here. You're going to practice this over and over. In your textbook, it has some examples. For example, fluorine changes to fluoride, chlorine to chloride, bromine to bromide. And also, here are some elements that come together to form ionic compounds. Sodium and chlorine make sodium chloride. Calcium and bromine make calcium bromide. So we can write out the whole name. So for example, here we'd have calcium iodide. But that can get very tedious writing all these words out all the time. So it can be easier just to use the symbols of the elements. So calcium, this should be 2+, and iodine, 1-. These come together to make CaI with the little subscript 2. So this subscript is the 2 at the bottom, CaI2, just to make it more clear there. The small number to the right of the symbol is the subscript, and it tells us how many of that element is in that compound, and it tells us the ratio. So for example, there are 2 iodides per calcium. So let's look at this one. Calcium has no subscript, so we can assume that's just a 1. So there's 1 calcium per 2 iodides. So figure 4.21 has some great examples in your book, and table 4.5 lays it out really clearly. Here is figure 4.1 on the side, and we see that if we have 6 positive aluminums and we have 2, 4, 6 negative sulfides, then we can put that there are 2 aluminums per 3 negative sulfides. And we have 2 positive magnesiums and 2 negative chlorides, but we need 2 chlorine atoms to balance out the 2 plus. So we need 2 of them here. So as you can see, we're trying to balance out these charges here. This positive and this negative need to balance out. So that's why we may need more or less of these certain ions. So they help to balance out the ionic charges. Let's look at an example. I've got for you magnesium 2 plus and phosphate 3 minus. These come together to make magnesium phosphide. Now the thing is, we need to have some subscripts, so let's move this P over a little bit. And how do we know exactly how many to put? Well, I have a little hint for you. We could take this top ionic charge and send it to the subscript of the P, and take this top ionic charge and send it to the subscript of the magnesium. So what we'll get is magnesium 3 phosphide 2. So this will be magnesium phosphide. And this is the correct naming for this ionic compound. Let's try another couple just to make sure we're all on the same page. Sodium and bromine, they come together, Na plus and Br minus. Well, you'll see that they both already have a charge of 1 plus or 1 minus. So when we have the bromine, the 1 minus is just a 1 down here, and bromine 1 plus, it'll just make a 1 down here. So we could really just say this is NaBr. And let's name this in words just to make sure we all know how. This would be sodium bromide. Let's try zinc oxide. Zinc, symbol is Zn, 2 plus, and oxygen is 2 minus. So when these come together, we would get zinc with the 2 here going down to the subscript of the zinc, and the oxygen with the 2 up here going down to the subscript of the O. But over here I told you that that this is the ratio. So we don't need 2 per 2. We can express this in reduced terms. So 2 divided by 2 and 2 divided by 2 is 1 zinc oxide, like that. And we could write it out zinc oxide in words. Well, there you go. Now you know how to name ionic compounds. Please be prepared in class next day to practice this further.